Welcome back. So binomial theorem, as I said in the previous video, gives us a way to get our result of algebraic expressions, especially when it has to do with large powers, without necessarily expanding the brackets. If we have x plus a power n, where n is an integer, we can use binomial theorem and the Pascal's triangle to figure out the results. The final element that we need in order to put everything together is to understand what happens to the values in the bracket, in this case, which are x and a. Remember, we've said that with the Pascal's triangle, each level represents the power. So the first level is level 0, which represents when n is 0. The next is when n is 1, and so on till we get to wherever the value of n stops. We've also said that each of these numbers that make up the triangle are the coefficients for that particular level or for that particular power. So when n is 4, we have 1, 4, 6, 4, 1, which represents the coefficients. So the last thing we need to know is how the actual values in the bracket change as we move between the coefficients. The way it works is that as you move through the different terms of your result, you change the power of these two terms in the original expression. Let's see it in action. So we're saying if n equals 4, we know that the coefficient of the first term in our answer is 1, so we write 1. The first term in our algebraic expression is x, so we write x. And then we maintain power n, and then a power 0. The next coefficient is 4. X is still first, but now we have to reduce the power of x by 1. So it becomes n minus 1. And then a gains a power which is from 0 to 1. The next is 6. We have x. We reduce the power of x again, so it's now n minus 2. And then a power 2. Next is 4. We write our x. We have n minus 3. And then we have a power 3. And last, we have 1 again as the coefficient. We have x power n minus 4. And then we have a power 4. If we break everything down, we have 1 x power 4, and a power 0 is 1, so we don't need to put that down. Next, we have 4 x power, since n is 4, 4 minus 1 is 3, and then a power 1 is just a. Then 6 x power 4 minus 2, which is 2, and then a power 2. 4 x power 4 minus 3, which is 1, so we can just write x, and then a power 3. And lastly, 1 x power 4 minus 4, which is x power 0, is 1, so we don't need to write the x there, and then a power 4. Easily, we've been able to knock out as many as 10 steps that we would have had to get through in order to get to this answer, and we have already arrived at it in 2 lines. That's the beauty of binomial theorem.